So again, we want to use the same property. So see, what is the situation now? Thus, what we have, what is the situation? This is thus for any real numbers minus of absolute value of x is less than or equal to x, less than or equal to absolute value of x. This is true. No, doesn't matter x is positive or negative, but absolute value is always positive. So minus of absolute value x is negative. And right now I am going to use order property. Which order property? A less equal b, c less equal d, then a plus c and b plus d. Can I say that less equal?
Yes, sir.
Right. So similarly, so if I want to use this order property, then if I just look at this half inequality and this half inequality, right, and if I add left hand side, so if I add left hand sides, minus of absolute value of x plus minus of absolute value of y is less than or equal to x plus y. Am I right?
Yes, sir.
Yes.
Right. Now at the same time I will add now this half part, this half part, x less equal absolute value of x, y less equal absolute value of y, and then I will add, so less equal absolute value of x plus absolute value of y. So I am writing in same expression, but basically I am adding these two inequalities, right? So what is this? This is basically minus of absolute value of x plus absolute value of y is less than or equal to x plus y less than or equal to absolute value of x plus absolute value of y. Now this the situation is like, how this situation, if I call this as a, right, and this has some number whatever you can say u, and this is again a, so what is the situation? Situation is like this. What is the situation? What is situation?
U less than equal to absolute value of U is less than equal to A.
Right, the situation is like this. So what is my a in this case? Absolute value of x plus absolute value of y. Absolute value of x plus absolute value of y, and here negative of that number, same number, right? So if I call this as a, then here it is minus a, and whatever is the middle number, because x and y are real numbers, so x plus y is some real number, whatever it may be. So what is the conclusion? By previous inequality, by this, these two are equivalent. This implies this or this implies this. So what is the next step?
Mod of u.
So absolute value of middle number is less than or equal to whatever the number here, absolute value of x plus absolute value of y, which is what we wanted to, which is required. Right, so this is what we wanted to get immediately, and therefore this is very essential, important property of absolute value that we can directly use here. Right, so the triangle inequality here we can say now. So more generalization. So of absolute value. So if you want to generalize absolute value, so define for this triangle inequality. This is fine. We can prove it using this property. So if you define T for xy real numbers, if I define d xy is equal to, or before that, what I should say, not dxy. For any two real numbers x and y, what I want, what is the difference between x and y? What is the difference xy? For xy belongs to R, if you look at two real numbers x and y, then what is x minus y? What is x minus y?
Negative.
Negative, right? But y minus x is positive, right? But if I take absolute value of x minus y, then doesn't matter which is greater and which is smaller. If I take absolute value of this, then it doesn't matter which is bigger, which is smaller. And actually what it gives, suppose 0 is here, and even I am saying ki y, this is y distance, and this is x distance, and what is y minus x? This distance, right? This is y minus x. But this is same as x minus y, provided if I take absolute value. Right. So if numbers are negative, then also same thing is true. So absolute value of x minus y is the distance between x and y, right? Do you understand this? Absolute value of x minus y is the distance between x and y. So is it clear? Do you understand this? The absolute value
Yes.
of and doesn't matter which is bigger, which is smaller now. Suppose x is equal to minus 5000 and y is equal to 10. Then what is the difference and its absolute value? It is just distance. Right? Distance between minus 5000 and 10. So define a function t from r cross r to r. R cross r, you can understand Cartesian product of two sets. R cross r to r. Do you understand what is a Cartesian product of two sets?
Yes.
Right. Now if I say r cross r, then what is it? All those xy such that what type of pairs?
XY belongs to.
X is from this r and y is from this r, but both are same r, therefore xy are real numbers. Right. And if you identify these numbers as a points in plane, and if I call this as a first axis, that means first component coming from this, and I will call it as x component and y component, then I can identify elements in the plane, and therefore this is nothing but r cross r is nothing but plane, which is denoted by r2, not r square. Right? This is called as r2. R2 means r cross r, so plane. So I will take pair, right? When I define a function from r cross r to r, later on in algebra we will study detail about functions, but when I say I want to define function from r cross r to r, that means I want to take element from r cross r. That means I should choose a pair, and what pair I am going to do with this pair? I will select a pair xy from r cross r, and where it will be mapped to point in codomain, some real number, and what is that real number I am going to map is absolute value of x minus y. Right? Do you understand what I want to do here is? So I want to take two real numbers. That means I want to take a pair, right? And when I am taking pair, then I can define the absolute value of this difference, that means distance. Then what are the properties? D xy is greater equal 0 for all xy belongs to R. Is it true? Is it true?
Yes, sir.
So this is true because it is simply absolute value, and absolute value is always greater equal 0 by our previous discussion. Second thing or second observation, dxy is 0 if and only if when dxy is 0, if and only if absolute value of x minus y is 0. But by our previous discussion, absolute value of some number is 0 if and only if x minus y is a number now. Now it is just real number, whatever is difference of two numbers, but it is number, right? And its absolute value is 0. So if and only if the number is 0,
X.
right? The number is
Yes.
Or y.
right, and number is 0 if the x minus y is 0 if and only if x is equal to y. That means dxy is 0 if and only if x is equal to y. So dxy is same as dyx. Is it true?
Yes, sir.
That is what it says ki x minus y, absolute value of x minus y is same as absolute value of y minus x, because absolute value of y minus x is minus of x minus y, but absolute value of minus 2 and 2 is same. So similarly absolute value of x minus y and its negative is same. So that's why absolute value of x minus y is same as y minus. Right. What is fourth? dxy is less than or equal to dxz plus dzy. Right. If you choose any xyz real numbers, right, that is what absolute value of x minus y is always less than or equal to absolute value of x minus z plus absolute value of z minus y. So how this is? So what is this? The last property. What is the last property? What is the last property? Do you understand what is the last property?
The triangle property.
Yes, triangle inequality. Right? So last property is simply triangle inequality. Because what is by definition of absolute value of x minus y? What we are seeing here? Where is this? So x minus y, absolute value of x minus y is the distance between x and y. That we have observed. And therefore, what I am defining dxy is the distance between x and y is absolute value of x minus y because it is a distance. And what distance satisfies? The distance between 2 points is always greater or equal 0. Distance between 2 points is 0 if and only if they are equal. Right? Distance of x from y is same as distance of y from x. That is what this property is called as symmetry. This property is called as non-negativity. Right? And this property is called as triangle inequality. So this is a something general version of triangle inequality. Why it is a general version? Because if I have x point here, y here, and z here, and I want to measure distance between x and y. So distance of x from y is less than or equal to distance of x from z plus distance of z from y. Right? That is what the triangle inequality is. There are versions, different versions. And what is the proof? Proof is just. So what is the proof of triangle inequality? Right? Above three properties are trivial. But what is using the previous situations or previous discussion? What is the proof of triangle inequality? If we consider x minus y, then what I will do? I will add and subtract z. Right? So if I add and subtract z, the value x minus y remains unchanged. Am I right? Right?
Yes,
Yes,
sir.
sir.
And I will just separate in two brackets. And now this is a number, this is another number, and this is absolute value of sum of two numbers, right? This first bracket is a number because it's the difference of two real numbers is again a number. So first bracket is a real number. Second bracket is again the real number, and by our previous basic triangle inequality, what I can say? What is my basic triangle inequality? A plus B less than or equal to absolute value of A plus absolute value of B. Right. Now here this is A and this is B and this is sum of absolute value of sum. So what is it then?
Absolute value of x minus z plus absolute value of z minus y.
Right. Right. And thus what is the conclusion? Distance of xy is less than or equal to distance between x and z plus distance between z and y. No matter what x, y, z you select, right? So no matter what x, y, z you select. So this is a triangle inequality. The function here d is called as the distance function. Right. So why d is called as distance function? Because this d satisfies all the properties of distance. Because in our day-to-day life, what properties of distance we generally use? The distance is, we cannot say ki I traveled minus 5 kilometers today, right? We cannot say. So we always say that ki I traveled 5 kilometers. We always say that ki I have the length of table is uh, 3 feet, whatever. So every time when we measure the distance, it is a non-negative quantity, right? Every time distance of between 2 points, which point is first and which point is later, that doesn't matter. So distance between x and y is same as distance between y and x. And if 2 points are at same position, that means x is equal to y, distance is 0. And this triangle inequality, the distance of x from y is less than or equal to distance of x from z and distance of z. So all the properties, our usual properties of distance are satisfied by this function. Therefore, it is a distance function. And therefore, henceforth, whenever I need distance, I will use absolute value. Right. Now, and whenever I will use absolute value, it means that I am using somewhere distance. Right. That you should remember. So, this is the way we are generalizing the ideas. Right. But now natural question you can ask, when uh, dxy is equal to dxz plus dzy. When equal. Here I am saying less equal. So it is less, but sometimes equal, but when equal. Right? That question you should ask, or first of all you should ask it yourself, and then if you don't find answer, then we'll discuss. Second question. You think about this question, because this is not really difficult, but you should make habit of thinking on your own, right? And remember that if you understand mathematics better, you should have a habit of asking questions and generating valid questions, right? Sometimes questions might be silly questions, but if you don't know, then it is a genuine question, right? Anyway, so you just think about this. Is this the only way to define distance? As we discussed yesterday, I think we discussed it yesterday, we measure the distance from Pune to Mumbai by road, by air, by train, railway track. So these are the different ways to measure the distance, right? So is this the only way to measure the distance on real line, or distance between 2 points on real line, right? And what do you think? What do you think? So I will give you hint. If I define dxy, distance between 2 points, as x minus y upon 1 plus x minus y, right? Then we'll discuss this during practical sessions, or you can try on your own also. Then D satisfy all the properties of distance. And this is a very interesting thing. You can actually define distance by different ways. But this distance is not, this formula, distance formula is not useful in our day-to-day life. Do you understand?
Yes.
So this formula is not useful in day-to-day life, because in our day-to-day life, which distance we use? This distance. In our day-to-day life, distance between x and y is absolute value of x minus y. This is our usual way to measure the distance. Just choose 2 points on a line and take a tape and measure the distance, right? We directly measure the distance, and that what is that happening mathematically? We are just taking absolute value of x minus y. Practically, we take a tape and put one end here and another end here, and we measure the distance. But mathematically, we are taking absolute value of difference. So that is what the distance is. But this is also a distance function. This also gives a, because this expression, this formula satisfies all the properties of distance function. The only thing is, in day-to-day life, it is not useful. Then again, you can ask question, but if it is not useful in day-to-day life, it is not useful in day-to-day life is not correct actually. But in usual, common people cannot use this distance function. And what I mean to say common people means, in our daily routine, we do not use this distance, but it is useful in day-to-day life also. Where we use such kind of distance, we use it in various applications, like in your mobile softwares, in computers, everywhere, mechanical industry, right? Everywhere this kind of things is used, or designing, image processing, right? Signal processing, various applications, lots of applications, satellite, everywhere these kind of things are used, right? Do you understand this, what I am saying?
Yes.
Yes, sir.
Right. So the image taken by satellite is not clear, right? And so the image is blurred, and then there are pixels, right? And if you want to make image clear, so you have to define something about that point, so that you can get the more pixels and your image becomes more clear. So there are techniques that you will learn, mathematical basis of base of this whole business, whatever science, technology, and everywhere, the base is mathematics. Remember this, right? Unless mathematics, no technology will be successful.
Excuse me, sir.
Yes.
Sir, this is Shivendra here. I would like to ask that can we call this function a metric?
Yes. Very good. But
Sir, because even this is a distance function and even metric is defined in the same way.
yeah, that is what I am saying. But I did not wanted to use this word right now, because you are many people not aware of these things, and I should not use such words at this level.
Okay,
Right.
sir. Okay, sir.
That is the main point. Otherwise, if you read the advanced topic, then you can call it as a metric. And metric is a general name for distance.
Sir,
Yes.
because we studied in topology.
Yeah, right. Very good. So,
Sir,
yes.
sir, the answer to the first question is it that if x, y, z are collinear and x divides the line joining x and y in a ratio?
Yeah, that is correct. That is actually the answer, but you will prove it. Write down the detailed proof. Right?
Okay, sir.
Yeah, and you can further think about this particular function dxy is equal to this also satisfies the properties of distance, whatever our usual properties, visual perception of distance properties. The idea, central idea behind distance is these properties, and anything satisfying this property is a distance. That is the main point. But anyway, if you learn higher mathematics, you will by that time you will have the all basic concepts, and then you can understand it later. But right now it is not. Don't bother about this. You just think about it. Right. Now, so नाही येत आता माझं लेक्चर चालू आहे कमी. So this is the one way you can define the distance between 2 points. So there are many other ways also, right? So I should not tell you very difficult things at this level, but I just to increase your curiosity, I can define dxy is equal to minimum of 0, right? This I can define as a distance. So if x is equal to y, then minimum is 0. So you also check that d satisfies all the properties of distance. But as I told you before, these are not useful in our day-to-day life, right? These are, it has all these things are applications in various things like technology, data science, right? If you have a various data, and then you can cluster the data, and clusterization is very essential in artificial intelligence or data science. And you want to cluster, you want to define your distance function, and if you define your suitable distance function, your data is suitably can be clustered, and that cluster is helpful in for artificial intelligence or whatever, right? So these are the many technology applications that you can have, but we are a very initial stage, so we are learning these ideas from root, right? That's fine. Okay, now another version of triangle inequality is prove that for xy belongs to R less than or equal to x minus y. It's just one more version. I can say version because its expression is different, and I want to basically use our original triangle inequality, right? So let I will select real numbers. I will select real numbers. Then x minus y plus y. What I am doing, I am adding y and subtracting y. I have just selected arbitrary, right? Remember that key. What logically I am doing, what philosophy I am using. I am not choosing particular. I am just closing my eyes and I am putting my hands in real numbers, and I selecting two numbers whatever I get, and I am working with those numbers only, right? Remember this. And therefore while writing some proofs, solving some problems, don't restrict to whatever notations I am using or whatever method I am. So try to explore yourself, right? So try to think logically. Take your own notation A, B, C, D, whatever you want, and apply your own logic, right? So don't restrict to particular method and particular notations, and so try to explore yourself, right? So I am just taking x and y, whatever x and y doesn't matter. I am
Sir,
just
this is
now.
also called as hello.
Yes.
Sir, this is also called as reverse triangle inequality.
Yeah, the names can be different, and why names are different? Because people can have these kind of things due for particular applications or particular purpose. So for particular purpose, how it is used, accordingly people give the names, right? People investigate many inequalities and for particular purpose, and they give the name according to that purpose, right? So that happens always, right? Anyway, so this is x minus y plus y, right? And now it is just absolute value of sum of two numbers. And now can I use my previous knowledge? Can I use my previous knowledge?
Yes, sir.
What is my previous knowledge? This is less than or equal to
Absolute value of x minus y plus absolute value of y.
very good. And so ultimately what I found is this is less than or equal to plus absolute value of y. Now I can certainly add minus of, so absolute value of y is some number, whatever is. I will add negative of its on both sides. So absolute value of x minus absolute value of y less than or equal to x minus y. So let us call it as expression 1. Similarly, I will generate similar kind of expression by starting with y. Right, so I have just chosen two numbers. Now I restricted to these two numbers only. Whatever you select initially, just work with these two numbers. Is right, and it is less than or equal to y minus x plus absolute value of x. Right, and it is simply absolute value of x minus y plus absolute value of x, because by our previous discussion x minus y and y minus x absolute value is same. Therefore, absolute value of y minus absolute value of x is less than or equal to absolute value of x minus y. Fine. So, what is the situation? Therefore, let us call this as expression 2. Now I want to combine expressions 1 and 2. Right? I want to combine expression 1 and 2. So, from expression 2, what I have, minus of is less than or equal to absolute value of x minus y. Am I right?
Yes, sir.
Right, so I am just taking minus sign outside, and now I will multiply both sides by negative number, right? I will multiply both sides by negative number, which is minus 1. I will multiply both sides by minus 1. So what I will get? What I will get?
It's greater than equal.
Very good. So,
greater than or
right, so absolute value of x minus absolute value of y. Right, so let us, now I would like to combine expression 1 and 3. I will combine expression 1 and 3. So from 1 and 3, what is the left hand side of 3? Minus, less than or equal to. Okay. Now what is expression 1? See expression 1. Absolute value of x minus absolute value of y. And where I am right now, absolute value of x minus absolute value of y. And therefore from 1, what is it? This is less than or equal to?
Absolute value of x minus y.
Very good. Right, now what is the situation? Situation is some number a, some number here, and same number a here. So situation is like minus a less equal x less equal a. Same similar situations, right? So what is the conclusion of this situation? Right, so what is the conclusion? What is the conclusion of this? I have a here, I have some number whatever u here, and a here, and here minus a here. Correct?
Mod of
So absolute value of middle number. So absolute value of middle number. Right. Thank you. So absolute value of middle number is less than or equal to a, whatever is a, so x minus 1, absolute value of x minus 1. This is what we wanted to prove. And again, this inequality is also useful for at several purposes. So we need this for further use. So this is one more important inequality about this. Now we'll see some applications. Right, applications means some problems where we need absolute value. So determine state x such that x minus 1 less than 3, for example. So I want to determine the set of all real numbers for which the absolute value of x minus 1 is lies in between 1 and 3. So this set is easy for C, right? So what is given? So if number is in A, then what happens? That number satisfies this inequality. Which inequality? 1 less than 3. Right. Now let us think about half part. Now consider 1 less than x minus 1. Right. Just consider this half part. So absolute value of x minus 1 is greater than 1. What does it mean? Okay, recall this. Absolute value of x is greater than a or greater equal a. What does it say? If you remember previous properties, if absolute value of
Say
x is greater than a or x is less than
minus a.
if a is positive, right? If a is positive, and when we say absolute value of x is greater than a, for example, try to understand for simple case. So when I say absolute value of x is greater than 2, right? What are the numbers for which absolute value of x is greater than 2? 2 is positive, right? 2 is
everything
positive.
after 2.
Everything after 2, right? So x greater than 2 and x less than minus 2, because minus 3 also satisfies same condition.
Yes.
So we can use the graphical method here, no? It will be easier.
No, graphical method is okay, fine, but not every time you can use graphical method. In simple situation, it is fine. So what I want to tell you, when absolute value of x is greater than a, what does it mean? Or let me note here. Note, absolute value of x is greater than a, then suppose absolute value of x is greater than a, then what can you say about this?
X is either less than minus a or x is greater than a.
So if a is positive, then x is greater than a and x is less than minus a. Or therefore, if a is positive and the set x such that absolute value of x is greater than a, then this set is simply x such that x greater than a union x such that x less than minus. Right, if a is greater than 0, f is positive, a is positive, then when I say absolute value of x is greater than a, that means if a is positive, and when I say absolute value of x is greater than a, that means x is on this side or this side. So therefore it is what? A to infinity union minus infinity to minus a. This is what the different ways when absolute value of x is greater than a. But when I say absolute value of x is greater than a and a is negative, then what happens? If a is negative. For example, when I say absolute value of x is greater than -2, for example. So what can you say about this?
So, but it's not valid, no, as absolute value cannot be negative between 0 and -2. So many negative numbers are there.
Yes. So what? What are the x for which this condition holds? Can you see what are the x for which this condition holds? When I say absolute value of x is greater than -2. That means all positive numbers will satisfy this.
Yes.
Right. All positive numbers will satisfy this. Now which negative numbers will satisfy this?
Greater than, less than -2.
Less than. Suppose x is equal to -3. Does -3 satisfy this?
No.
Yes.
Why no?
It satisfies us.
Yes.
Yes, yes.
Yes.
Because whatever negative number you take, it is positive. So see
Yes.
what she said, ki for every x in R, doesn't matter it is positive or negative, absolute value of x is greater equal 0, and therefore certain it is greater equal -2. Right? If a is negative and the set x such that absolute value of x is greater than a and a is negative, then this set is a whole set of real numbers. Right? Is it correct? You take any real number now, whatever you want, and take its absolute value. It is greater than -2 because absolute value itself is non-negative quantity. So when I make general statement ki absolute value of x is greater than a, then what I am worried? I am worried about a is positive. A is negative, then nothing to worry, right? Because every real number satisfies this, right? For example, x such that absolute value of x is greater than -1 is whole set of real numbers. Every real number satisfies this property, no doubt. So what is the point to worry? Point to worry is if a is positive, then what are the x? So therefore, what is the important point? Important point is if a positive and absolute value of x is greater than a, then x belongs to a to infinity union minus infinity to minus a, or x greater than a and or x less than minus, right? Not and, it is or. Fine. Is it clear? That is what the point I wanted to note here, which property we forgot to prove. Correct?
Yes.
Fine. Now what is the situation? Our problem is this. 1 less than absolute value of x minus 1 is less than 3. Now let us just look at the half part. 1 less than. Now come to our original problem. So 1 less than absolute value of x minus 1. Right. What does it suggest? The absolute value of something, whatever is this amount inside the absolute value sign, is greater than 1. So from previous discussion, what you can say?
-1 is less than x minus 1 less than 1.
X minus 1 is greater than 1, or x minus 1 is less than minus 1, right? That means, so x minus 1 is greater than 1, it is equivalent to saying that x greater than, or this is equivalent to saying that x less than what?
0. And 2 and
Right, very good. That means when I say 1 less than absolute value of x minus 1, it is equivalent to saying that x is greater than 2 or x is less than 0. See, I am just using this simple property, either x greater than a or x less than minus a. That is what. So, and therefore x belongs to 2 to infinity, or x belongs to minus infinity to 0. Or means what? X belongs to minus infinity to 0 union 2 to infinity. Am I right? When I say or, that means it is union. Is it clear?
Yes.
Right. So when I say 1 less than absolute value of x minus 1, then x is in this range. That means x is definitely not between 0 and 2. Now next part of inequality. What is the next part of inequality? The absolute value of x minus 1 is less than 3. This is the next part. Right? So from this, now use previous knowledge and what you can write from this. What is the situation here? Absolute value of x less equal a. This is a situation, or less than whatever. This is a situation, right? This is equivalent to saying that what I should say here now.
X minus 1 lies between minus 3 and plus 3.
Minus 3 less than x minus 1 is less than 3. So that now I can add 1 throughout. Right, just you add 1 on this side or add 1 on this side. So just add 1 throughout, this inequality holds. So if I add 1 on this side, so minus 2 less than x less than 4. Right, that means x is in between minus 2 and 4. So the conclusion is, what is the conclusion? Therefore, what is the conclusion? 1 less than x minus 1 less than 3 implies what? 1 less than x minus 1 and x minus 1 is less than 3. Right? See, you have to be careful whatever I am using and or. So is it the correct word and?
Yes, sir.
Right. This implies you have to take care of such. I am using and or, so which is the correct? So this as well as this simultaneously and. But 1 less than x minus 1 is equivalent to saying that x belongs to minus infinity to 0 union 2 to infinity, and what this says, right, 1 less than absolute value of x minus 1 says that x is in this, and this says that x is in minus 2 to 4. And when I say and means what?
Intersection.
Intersection. Very good.
Intersection.
X belongs to minus infinity to 0 union 2 to infinity intersection with minus 2 to 4. Right? Fine. So just draw the picture here. Minus infinity to 0 union 2 to infinity this. This is the first part. What is the second part? Right, here 0 and here 2. So this onward is the first part. And what is second part? Minus 2 to 4. Now what is the common part?
Minus 1, 0, 1, 2, 3.
This is common part. This is overlapping because this part not was in the previous first set. So this is not in common. This is in previous as well as first as well as second. Right. So intersection. And therefore, what is this set? This set is minus 2 to 0 union 2 to 4. Right. And so what is the conclusion? Therefore, my set A, which was 1 less than absolute value of x minus 1 less than 3 is actually the set of those real numbers which lies in between x and 0 or 2 and 4, right? Or basically this is minus 2 to 0 union 2 to 4. Right. So how we determine this set? So we determine this set because we use the previous inequalities. Right. Now I will give you some exercises for you. Determine the following sets x such that uh, absolute value of x minus 2 less than 1 by 10. Right. C x such that 0 less than absolute value of x minus 1 less than 1 by 50. You have to determine these sets. D set x such that absolute value of x x plus 20 less than 1 upon, right, x such that absolute value of 1 less than absolute value of x plus 2 less than 10. F x such that plus okay, so you just try to explore this and simplify this and try to obtain the sets. If any doubts, next time we'll discuss more about it. Right, so any doubts so far? Any doubt? Any difficulty? Or everything is easy?